All right, even more partial fractions and a differential equation, yahoo. But we can do this, okay? We're just going to take what we've kind of been working on here and we're going to make it bigger, all right? First order of business, multiply both sides by dx because we want to get where we can integrate. And so when I do that, that leaves me with dy equals 6, it equals this. 6x squared minus 8x minus 4 over x squared minus 4 times x minus 1. So when we integrate this guy, it's going to be really disgusting looking. And so what do? We have y equals the integral of 6x squared minus 8x minus 4 over x squared minus 4 times x minus 1. So this is really a complicated looking problem. But if you look at the denominator here, this factors. And so we want to factor that denominator into x plus 2, x minus 2, and then we've also got x minus 1. And so we're going to actually set this fraction here equal to partial fractions that have 3 a, b, and c with them. All right? So what we're going to end up with is 6x squared minus 8x minus 4 over x plus 2, x minus 2, and x minus 1. So when we do our partial fraction decomposition, we're going to end up with a over x plus 2 plus b over x minus 2 plus c over x minus 1. And don't forget, like I did on the last problem, keep up with these minus signs down here. It'll make a difference, okay? We're going to multiply the whole equation by the denominator, okay? The whole equation by x plus 2. The whole equation by x minus 2, and the whole equation by x minus 1. Now this looks really, really troublesome, but look what happens. On the left, everything cancels out except for 6x squared minus 8x minus 4. On the right, the x plus 2's cancel out with a, so I get a times x minus 2, x minus 1, plus b, and then the x minus 2's cancel out. So that gets me x plus 2, x minus 1, plus c, and then the x minus 1's cancel out, so I get x plus 2, x minus 2. All right. This is a really complicated looking situation going on. And what we're going to have to do is figure out a way to solve for a, b, and c. Remember, those are the only variables that we can find, okay? They're coefficients here. And so what we're going to do is we're going to set each of these guys equal to 0 at different points, all right? So I'm going to need x to be equal to 2. I'm going to need x to be equal to 1. And I'm going to need x to be equal to negative 2. And so if I substitute those values in for x, that'll clean up a lot of the issues that I'm having. And remember, if we put it in for 1x, we put it in for all x's. So you're going to need some room to work. I'm probably going to have to erase and do things a couple times here, but we'll get the hang of it, okay? Let's start with x equals 2. If x equals 2, I'm going to have 6 times 2 squared minus 8 times 2 minus 4. I just simply substitute in my 2. All right? Now look at this. When I substitute in my 2 right here, I get 2 minus 2, which is 0. So the whole a term is going to be a times 0. And it doesn't matter what follows because a times 0 is 0. The b term then, if I put 2 in here, I get 4 and 1. So I'm going to have 2 plus 2 and 2 minus 1. The c term then, if I put the 2 in here, I get 2 minus 2. So my c term is actually going to be times 0. And if you'll notice now, all I have are b's. Okay, so on the left, I get 6 times 4 minus 16 minus 4. On the right, I get 4b. So now I just need to work this out. That's 24 minus 20. So my b is going to be equal to 1. Okay, that's not too bad. That's not too bad. All right, let's look at the next part. So now, now we're going to work with 1. Now we're going to work with 1. So if I put some 1s in for all of my x's, I'm going to put 1s in for all of my x's. So I'm going to have, notice right here, 1 minus 1. Okay, so that's going to give me what? 6 times 1 squared minus 8 times 1 minus 4 equals, well, 1 minus 1 right here gets me a times 0 again. All right, the 1 minus 1 here, look, here it is right here, 1 minus 1 gets me b times 0. And what I'm left with then are my c's. So I'm going to have 1 plus 2 times 1 minus 2. The reason this is legal is because I can pick values of x. That's the way we've always done it. Even back in Algebra 1 when you were graphing, you picked a value of x to get a value of y. So I'm picking very specific values of x that help me cancel out the items I'm not interested in. Okay. Notice that I'm going to be left with 6 minus 8 minus 4, which is going to be equal to c times 3. C times 3 times negative 1. Okay. What we end up here with is negative 6 equals negative 3c. So my c is equal to 2. All right, last guy. All right, this last guy is going to be the negative 2. He goes in now. So 6 times negative 2 squared minus 8 times negative 2 minus 4. And when you put negative 2 in right here, you're going to have all your a's. So negative 2 minus 2, negative 2 minus 1. And notice right here, negative 2 minus 2, that's a 0. And notice negative 2 minus 2 here, that's a 0. And so what you end up with is just the a part now. That is good news. So 6 times 4 plus 16 minus 4 is equal to negative 4 times negative 3. Okay? And so when I finish my math out here, this is 36 equals, yeah, hold on one second, negative 12a. And so a is negative 3. All right, that's my setup now, and we can start integrating from there. All right, so then let's set up our new integral. And we did all this work. It's actually going to be a much easier integral than this. We're going to go from y equals this really complicated, nasty looking problem to y equals the integral of negative 3 over x plus 2 plus 1 over x minus 2 plus 2 over x minus 1. The reason we love this is because all of these x's down here don't have a coefficient in front of them. So when we integrate, it just integrates straight to the natural log of whatever is in the denominator. And our final answer then is actually not too bad, okay? So y equals negative 3 times the natural log of x plus 2. And remember, we're going to use absolute value bars here. Plus the natural log of x minus 2 plus 2 times the natural log of x minus 1. plus C. And we can put all these together if you want to. They might clean up a little bit nicer that way. And it's actually not hard. They're all adding, which means it's all multiply. And we can add our the numbers in front. Remember, they become exponents on the inside, so we can do all of that if you want to as well. So it's really not too tricky of a problem to sort through. And anyway, so there you go. There's that guy. And again, this is nice integration. So let it be nice integration. Don't fight it and make it harder than it is.